the opening problem from the PowerPoint, the Liang PowerPoint, and it says, supposing you were confronted with the challenge of reading 100 numbers and then to compute their average and find out how many numbers are above the average. Well, up until now, it hasn't been that hard to figure out what the average is, but the second part of this problem is the real challenging part now, and that is how to find out how many numbers are above the average that you've calculated. Up until now, you've used for loops to do that. Using arrays, you'll be able to go ahead and do this complete problem without much difficulty at all. Let's first introduce arrays by getting the definition. An array is a data structure. Okay, that's a new concept. It's a data structure that represents a collection of the same types of data. Okay, so a data structure we'll talk about more in depth, but when you create an array, you have to keep in mind that the array is going to contain data that is of the same data type. Here's an example. We have an array of doubles. This is how you can read this. Okay, these left bracket, right bracket syntax indicates that we're going to declare an array. It's going to be of the type double, and we have a reference variable, mylist, and that is going to be the reference variable for the array. This is the declaration part, and then the equal sign to the right of that is where we're going to actually create that array in storage. The new keyword will create the object, the array object, and this double keyword has to be the same as this double, and this 10 inside the brackets indicates how large the array is going to be. This statement here will go ahead and create this array referenced as mylist, so you can think of that as a variable name, but it's actually a reference variable, which means that there's a pointer. This has an address. An area in storage gets created that has an address that points to the object of the type array somewhere else in storage. And when we issue this new keyword, it's going to actually allocate and create these 10 elements, and you can reference these 10 elements of type double by typing in mylist sub 0, mylist sub 1, mylist sub 2, all the way down to mylist sub 9. There are a total of 10 elements, and they contain the specific doubles inside those areas of storage. And it is zero-based, which means that the first element is mylist sub 0. The second element is mylist sub 1. It's going to be off by 1. The last element, mylist sub 9, is really the 10th element in the array. The contents of that element is 11,123. The first element contains 5.6. Okay, so that's how you can understand what happens when you create an array. There are two ways that you can create an array or declare an array. The first way is to do it the way we just described, which is to declare the data type first, followed by the left bracket, right bracket, and then the reference variable name. There is another way, and the origin of this is derived from the C programming language. They decided to adopt it, but it's not used that frequently, and that is essentially to take the brackets and instead of putting them here, move them to the end of the reference variable name. Both work, but the second type, this double mylist, open bracket, close bracket, semicolon, is not preferred. It's more for the C programming language. Here's repetition. We've already covered this. So we'll go to the next slide. And this really is repetition as well. This is what we just described here. This is declaring and creating all in one step. The left-hand side is declaring, the right-hand side is creating. Now, once an array is created, its size is fixed. You cannot change the size of the array that you have allocated in storage. You can find its size using the array reference variable .length. For example, in the case of the previous slide where we declared and created an array whose reference variable name is mylist, well, if you wanted to find out the length of that array, you can code in mylist.length, and that will return a value of 10. That gives you the length of the array. So you can know right then and there that the array has elements 0 through 9, if you need to reference those elements inside the array. When you create an array, its elements are assigned a default value. The default value for the numeric primitive types, that's int, that would be double, short, long, it's going to be 0. For the char data types, you're going to use the Unicode character, the \U, which is the escape character, and then 4 zeros. Now these are hexadecimal zeros representing half bytes. So we have 2 bytes being referenced here, and when you create an array of chars, it's going to be assigned a default value of hex zeros in each of the bytes, the 2 bytes for the char data type. And obviously false for Boolean types. We do know that Booleans can be true or false, that's it. And specifically if you're looking inside the byte or the bytes, anything that is 0 is going to be false, considered to be false, and anything that is not 0 is going to be considered to be true. So declaring a Boolean type array will have zeros inside the elements, the value zeros. All right, index variables. The array elements are accessed through the index. Repeating what I said, the array indices are 0-based. In other words, it starts from 0 and goes to the array reference length, array ref var dot length minus 1. Each element in the array is represented using the following syntax known as the indexed variable. And you can go ahead and put inside the brackets the index variable, the index of the variable, the reference variable, and you will then have access to that element inside the array. After the array is created, an index variable can be used in the same way as a regular variable. They're identical. You can think of them as being identical for that data type. For example, the following code adds the value in mylist sub 0 and mylist sub 1 to mylist sub 2. What we have here is an array of length 10. The first element in the array we can reference as mylist sub 0, whatever the value is inside that element, added together with mylist sub 1. I don't recall what was inside that array, but if you take those 2 values, add them together, and assign them into the third element in the array that you can reference as mylist sub 2. It acts just the same way as any other primitive data type in your previous assignments. Here's a way in which you can initialize arrays. So this is declaring, creating, and initializing all in one step. First thing we start off with is the data type. This is what's going to be inside each element in the array. So we have an array of doubles. The array reference variable is mylist, and we're assigning these values into the array. We now know that this is my list sub 0, my list sub 1, my list sub 2, and my list sub 3. So we have 4 elements in the array, and these are the actual values inside each of the elements. This shorthand statement must be done in one statement. In other words, you can't break it up into 2. I think here they do that. So this statement here, which we just described, is the same as if you were to do this. Declaring an array of doubles, the reference variable name is myList, equals the new keyword. Now we're going to create an object in storage, and it's going to be of length 4 of doubles. And now you can assign any value you care to in each of the elements in the array. In this case, we're assigning 1.9 into the first element, 2.9 into my list sub 1, 3.4 into my list sub 2, and 3.5 into my list sub 3. This is wrong, so don't do this, which is basically to break it up and then do that. You need to declare it all in one step. We're going to trace a program right now. We have a public class test. Here is the actual class. It starts here, it ends down here. And we have a public static void main method starting right here and ending right here. And the first thing that we do is we declare and create an array of integers. The array reference variable name is values right here. And the new keyword will actually create this in storage, and it's going to be of length 5. As we described earlier, they are going to be initialized with zeros because it's a primitive numeric type int. We now have a for loop. And for int I equals 1, so we're declaring a loop control variable called I. It's going to be of the type int, and we're initializing it to 1. We'll go in this for loop for as long as I is less than 5. And for each iteration, we're going to bump I by 1. So I becomes 1. I is less than 5. 1 is less than 5. So we're going to execute the contents from within inside this for loop. What are we doing? We're taking I, which is 1, plus values, and here we have I minus 1. I minus 1 is 1 minus 1, so that's value sub 0. So we're taking the first element in the array, which is 0, and adding 1 to it. So 1 plus 0 gets assigned into values sub I, which is 1. That now gets placed in the contents of this element, in element 1, the second element. At the end of the loop, I gets incremented to 2. 2 is less than 5, so we continue iterating through the for loop. Now, what are we doing now? I, which after the line is executed, values sub 2 is 3, which is going to be equal to 2 plus 1. This is 2 plus value sub 2 minus 1. So that's down to value sub 1. So it's going to be 2 plus 1, which is 3. Now, that now gets assigned into value sub I, which is 2 down here. It's a little tricky, but it demonstrates pretty effectively that you can go ahead and assign variables, or assign elements using this simple algorithm. Now I becomes 3. We still stay inside the for loop because it is less than 5. And now it's going to take 3 and add it to values 3 minus 1. And that's where we get 3 plus 3 is equal to 6. After this, I becomes 4. It's still less than 5. We still do the for loop. And now, value sub 4 becomes I, which is 4, plus values of 4 minus 3. So 4 minus 4 plus 6 right here becomes 10. That gets assigned into values sub 4 over here. Next, I becomes 5, and it no longer is less than 5 because it's equal to 5. So we get out of the for loop, and we come down to this instruction right here. And it's got a little different approach to evaluate. We have to still assign something into element 0, and the way that they're going to do that is to add whatever is in value sub 1 together with value sub 4. So value sub 1 is 1 and value sub 4 is 10. So we're going to add 10 and 1. We're going to make it 11. And 11 gets assigned into the first element in the values array. And now you'll see that that's what happens. The next slides are some very handy routines to do some mainstream processing. The first is to initialize arrays. Let's look at this. Here's a snippet of code. We're first using the scanner for input, and we're going to ask enter as a literal string, concatenated with mylist.length. So that's a good application for when you want to identify the length of the array. And let's say the length is 5, so it will say enter 5 values, concatenated with the string values, colon, blank, close quote. So the console will have enter 5 values, and you're going to now go for int I equals 0 for as long as I is less than mylist.length. Okay, so that will go 0 through 4. And now we're going to go ahead and increment I for each iteration of the loop. We don't need curly braces for this because there's only one statement inside this for loop. And we will now get from the console input.nextDouble, because this is an array of doubles. My list is an array of doubles. And you can go ahead and enter doubles into your console, and it will get assigned into the first element in the array and continue through the fifth element, from element 0 up through element 4. That is a good way in which you can initialize an array using the console. Here's an example of initializing an array with random values. Same type of an approach. We don't need the scanner, but we can go ahead and do a quick for loop for int I equals 0, and we're going to go for as long as the length of the array. We're going to increment I by 1 for each iteration, and we're just going to go ahead and use this math.random method, which returns the fractional second from the system clock, and we're going to multiply it times 100. And that will randomly generate numbers, integers, from 0 to 99, and assign them into the element in my list. And it will do it for every element inside the entire array. So that's initializing arrays with random values. To print an array, for int I equals 0, and we're going to go for as long as the list length, the my list length is. We're going to just do system.out.print, my list sub 0, concatenated with a blank. We're using the print method, not the print line method, so this will now concatenate the elements in the array together with a blank in between each one as it loops throughout the array. it will print it out on one line. Okay, if somebody could please put their audio on mute, it would be terrific. Okay, here's summing all the elements in the array. First thing that we're going to need is an accumulator. We'll call it total. It's going to be of the type double, and we'll initialize it to 0. Now we've got a for loop that will go from int I equals 0 for as long as my list length. And we are going to do total plus equals, which is the same thing as saying total equals total plus my list sub I. So we're accumulating every element in my list and putting it into the accumulator variable called total. When you drop through your for loop, you've gone through the entire array and you've totaled every element therein. Finding the largest element in the array. We will go ahead and declare a double variable called max, and we're going to initialize it to whatever is inside the first element in my list. Okay, I'm getting some feedback, so if everyone could please put their audio on mute, it would be very helpful. Thank you. Okay, we lost that, I think. All right, so what's this first line doing? It's taking the first element in the array and assigning it into max. Probably a good idea because as you traverse the array, the first element is going to be, at that point in time, the largest. So you'll assign max the first element's value. Now we're doing a quick for loop, and we're going to start with 1 instead of 0 because we already processed the first element. Whatever that value is the max. Now we're going to go for the remaining elements, and we're going to do for int I equals 1, and we're going to go for as long as I is less than my list.length. We're going to increment I by 1, and we're going to say if my list sub I is greater than the max. I'm not a big fan of this. It should be on 2 lines, but what they did was they did a shortcut, and they said, then we're going to assign that element into max. And this will continue and loop through the array. And if the next element is larger than what we've currently stored in max, it now becomes the new max until you're done with the array and you've dropped through this, this for loop. Any questions so far? I've done a lot of talking. I just want to make sure that people can pipe up and speak up. I want it to be interactive. Anybody have any questions? I'll just look to see if there's any raised hands. I don't see any. Anybody want to just make a comment? Okay, Alyssa says good so far. All right, so we'll continue on. All right, now this is a little tricky here, and this is random shuffling. I don't know that there's that much of a need to do that, but, and I'm not going to step through each one of these lines of code, but this is another for loop using I and J, loop control variables, I and J, and it does some, what is it doing? It's doing some random generating and swapping. I'll let you follow the logic in this at your leisure, but if you have a need to shuffle elements in the array, if you're creating a game of cards, for instance, and you want to shuffle the deck, this might not be a bad way to do it. You could create an array of 52 elements and shuffle the deck by using this random shuffling. I'll call it a method. It's really a for loop, but it is a method. Shifting elements in the array. We have a variable called temp. It's of the type double, and we're going to now put the first element in my list into the variable temp. We're retaining the first element. Now we're going to look to this good line comment here, shift elements left. So for int I equals 1, and we're going to go for as long to the end of the array. We are going to take my list sub I, my list sub 1, and enter it into my list sub I minus 1. That would be 0. So we're basically taking the second element in the array, that's my list sub 1, and moving it into the first element. And that explains why we saved the first one, because we didn't want to clobber it in the first iteration of the for loop. We saved it into a temporary variable. Now we can go ahead and follow this for loop, and it will continue on and keep shifting to the left each element by 1. And then you've got to go ahead and do something with this temporary variable after you've dropped through the for loop and move the first element from the temp variable over and put it in the last position. And that's essentially what this is doing here. It's taking the variable temp and putting it into my list sub mylist.length minus 1. And that will put what was in the first element and put it into the last. That's shifting elements. The JDK Java Development Kit 1.5 introduced a new for loop that enables you to traverse the complete array sequentially without using an index variable. I don't know why they did that. Everything was working fine before JDK 1.5, but they went ahead and chose to do this. So for example, the following code displays all elements in the array called mylist. And just memorize the syntax. For double value colon mylist system.out.println the value. In general, the syntax for whatever the element type is, you can call it value, you can call it any conventional name, and the array reference variable name, and then process the value. You still have to use an index variable if you wish to traverse the array in a different order or change the elements in the array. But if you just want to do this very simply, they allow you to do this type of coding. Our opening problem: read 100 numbers and compute their average, and then find out how many numbers are above the average. All right, let's look at analyze numbers. Oh, okay. For you online folks, what I've suggested that the on-ground students do is, as you're going through these PowerPoints, and Ramil and Phil, and maybe this might be helpful to you, is what I ask people to do is to create a test chapter package in NetBeans. So in this case, I've created a test chapter 7 class inside this package. And whenever I get something inside a PowerPoint that I would want to test, I copy and paste it in and I execute it. And so all those PowerPoint slides that we just went through are all right here in workable code. I suggest you do that. It also, as you go ahead and copy and paste it and execute it and get it to run and troubleshoot it and clean up syntax, and you're going to have other questions that come up in your mind that may be easier to answer if you have this test chapter whatever, we're up to chapter 7 now, this test chapter 7 package available to you. So that's what I do, and I have this right here. I'm going to close this package out. I'll save it and open up Analyze Numbers. Here is the code, rather straightforward. Seemed like a pretty daunting problem when we first proposed this at the beginning of this webinar, but this doesn't seem like a terribly complicated solution now. Let's go ahead and take a closer look. We have a class called Analyze Numbers. It goes from here down to here, and inside there is one method. We're back to using just one method now, a main method, beginning here and ending there. So that's the whole class right here, is this main method. Inside the main method, we are declaring an array of doubles. The array reference variable name is scores, and when we use the new keyword, it will actually create that array. Its length is going to be 5. So now you can envision an array of length 5, so that's going to be scores sub 0 through scores sub 4. We're also looking to accumulate, because after all, we need this average. And then we're going to look to see how many grades are, or scores are above the average. So you'll need an accumulator variable. We'll call it sum of the type double. After all, grades could, or scores could be 97.5. So we want to declare them as doubles. We're going to get scanner input, and we're going to do a quick for loop. We're declaring I within our for loop as an integer variable. So for when I equals 0, and I will go for as long as scores.length, which is going to be 5, and we're going to increment I by 1. We'll bump 1 for each iteration. In here, we've done the scanner, so we're going to get system input, and we're going to ask, enter a new score. The next double method inside the scanner class is going to take that entry and assign it into the scores array in that appropriate element number. In this case, it's going to be 0. So scores sub 0 is going to get the first score. What are we going to do next? We're going to take that first score, let's say it's 97, and accumulate it into sum. Sum plus equals 97 is the same thing as saying sum equals sum plus 97. So we are accumulating each of the scores for this test, or whatever it is that you're accumulating. We'll continue on for 5 iterations. And then at the very end, after the for loop, we've now gotten 5 scores inside our array. And we're going to take the sum and divide it by scores length in order to get the average, and assign it into the average of type double. Now we've calculated the average. Now we can go through this array again that we've created, and we're going to start by initializing a counter to count the number of elements above the average, and we'll do a quick for loop. We can use I again. We can declare it again because this I is only as good from there to there, so we can declare another declaration of I inside this for loop. We'll initialize it to 0, and we'll continue on for the length of scores, which is going to be 5. And we're going to ask the question, if scores sub I, which is 0, whatever that score is greater than the average, which is right here. The average is 70. Well, then we're going to add 1 to the counter. And then we will continue on, and for every score that's above 70, whatever our average happened to be, we're going to add 1 to our counter. We'll traverse through the array called scores until we fall through the for loop, and we will then go ahead and execute these last 2 print statements and say the average is, whatever the average is, I said it was 70 if that was the calculation, and then we'll go ahead and print out the number of elements above the average is going to reside in the variable called count. So it's a simple solution for what looked to be a rather difficult proposition, all by using arrays. Hopefully you all can see the value of using arrays, certainly with this simple problem. I'm going to run this program, and we'll get this to perform live. Enter a new score. I'm going to just put simple ones, and I'll put 1, 2, 3, 4, 5, so we can keep track of, easy to keep track of this. So I've entered 5 scores, 1, 2, 3, 4, 5. The average is 3, and the number of elements above the average is 2. That would be score 4 and 5. Okay, we got that? Everybody kind of got an idea as to how to use an array? And then using for loops. For loops are perfect for arrays because you know how long the array is. You can always get the array length by using the array reference variable name .length, and then loop through using a for loop through the entire array. And you can then take another pass through the array in another for loop. So it's a second analysis.